So we're looking at the sequence. It's actually a series because of the plus signs there. And we want to identify whether this is arithmetic or geometric. Now, if it was arithmetic series, then that would mean that there's a common difference between those successive terms. So I would be looking for the addition of the same number every time. And if it's geometric, then I would be looking for a pattern that looked like it was multiplying to get the next term. So when I look at this, to get from 3 to 7, I think, well, that's a +4. And then I want to check and see if that stays consistent, if it's common between those terms. And it really is. So we can check between each one. So that means that 4 is our common difference, which we represent with a D. So we have an arithmetic series right there. To write the recursive formula, there's two parts to a recursive formula. We start by saying what our first term is, which is just the first term. In this case, it happens to be 3. And then the second part of the recursive formula, we say that an, which just means we can get any term by taking an minus 1, and that little subscript notation means the previous term, and adding 4 to it. So that's our recursive formula. Now we need to write the explicit formula, which is a little bit more useful for making number calculations. And since that's an arithmetic series, we have a certain formula for that. So to get any term that we want in that pattern, we can take the first term, so A1, plus n minus 1 times the common difference. Now all we need to do is plug in the numbers that we have for the first term and for the common difference. So I can get any term by taking the first term, which is 3, adding n minus 1 to it, and then multiplying by the common difference. In this case, that's 4. And that is my answer for the explicit formula. And we just leave n as n because that is a formula that can be used to find any term that we're looking for. So to follow up that question, they ask us to find A15, which means the 15th term in that pattern, which means we are going to be substituting 15 for n. And we're going to be using that explicit formula. So A15 is 3 plus 15 substituted in for n minus 1 times our common difference. And when we plug that all into our calculator, we end up getting that A15 is 59. So that's our 15th number in that particular pattern. Now, the next question is an arithmetic sequence over here, and they want us to evaluate the summation on the first through the 10th term there. And this is not the same pattern here, but a totally different problem. So one thing that we can do is put it in our calculator using the TI-84, but I will also show you how to do it by hand here. So since we're looking for a sum, I want to think about what that general formula is. So S for summation is n divided by 2, and this is one of a couple different formulas. 2a1 plus n minus 1 times the common difference. So we can plug in the numbers that we have. Our summation is through the 10th term, so I'm going to make that subscript say 10. So our n is 10 divided by 2 times a1. So I need to figure out what is the first term in this pattern here. So what that means is I would want to plug in 1 for n. So I'm going to just go up here and find out what we would get. So 4 minus 7 times 1, and 7 times 1 is 7. So it's really 4 minus 7, which happens to be -3. So let's go ahead and substitute that. -3 in for A1, and then we're adding n minus 1. Oops, let's see. What I really want to do is plug in the number. So in this case, our n is 10 minus 1. And the common difference in this case, that's going to be the number that's multiplying my variable or multiplying my n. Our common difference here is negative 7. So let's substitute negative 7 in. And then we can start to simplify that. So 10 divided by 2 is 5 times. And then 2 times negative 3 is negative 6 plus 9 times negative 7. Simplifying that more, we get 5 times negative 6 minus 63 there. And final answer would give me negative 345. And you can do that in your calculator or by hand. And that's my final answer on that. And the next video will show you how to put that into your calculator.